Okay, I think we're good now. Okay, so we've got our little line drawing thing. Got our circle. It's all good and happy. So let's close out of that, and let's take a copy of this file, imgui.cs, and we'll call it physics game. So basically, so that we have a spare while we mess with stuff. So the first thing we're going to do is just go through this because we've collected a whole lot of cruft. So let's delete some stuff we're not using. Starting at the top, and yeah, I'm going to follow you on this one. So,
all right. Well, sprite batch. It's the obvious first thing because I'm not using that anymore. Don't need the white pixel, right? Unless we're still using it.
We can always bring it back.
Yeah. Okay. I don't think we're using it though for anything because this obviously sprite batch related. I think we need all of these still. Maybe I'll move them to the top. I'm not sure.
I'd usually leave those above load content because that's what uses them. But also, those are what's drawing our triangle, and we don't really need the triangle, so we could get rid of those.
Yeah, good point. Maybe we can just hoist this up and kill this method, I guess. I don't know. Unless you wanted to
leave that one for now. I think it's probably going to be wise.
We'll have a little bit of cleanup to do up here in your draw. Basically all of this. And probably don't want this anymore. The false conditional. And this goes away. And we don't need these.
Yeah, we don't need those testing lines. I don't think we need thickness either, because that will get a squiggly.
Where's that? I don't see that. Oh, I already got rid of it. Okay.
Yeah. Yeah. So this is all the vector line drawing, so yeah, we're going to use that.
Okay, well, all of these methods here, we're going to probably keep them somewhere, or we don't really care about them anymore?
We don't really care about them. That's why we kept a copy of
the
other file. Sort of lack of version control. I think that looks about it. So in theory, if we run it again, we won't get any errors, and we still get to do this. Good. Okay, so now we've removed about half the code in there, which is, it's always good to have a bit of a cleanup. So we've got this sort of nice section here. Let's hoist that out into a class so we can reuse that.
Okay. I don't know if I have the same exact comment. Okay, yeah, I see it. All right. So we'll call it what?
I usually call this one line batch after sprite batch.
Makes sense. Yeah, okay. I'm not sure about max lines, but I'll take it. Yeah.
So if you're wondering, I mean, you can always find all references, but yeah, that is required.
Okay. So yeah, okay. For now, I'm just gonna literally cut and paste that stuff down here.
Pretty much.
Except for well, there'll be some.
Well, now we have to fix up everything that we've changed.
Right. So we need a graphics device in the line batch. Hopefully this isn't too loud with the keyboard.
People on YouTube love mechanical keyboards.
Oh, yeah, I'm using my a different style here, so I might want to switch to your convention and just get rid of the underscore. Just
Yeah.
let's have it. Okay. Well, there's a lot more to do here, but let me think. Um, you don't usually like to declare these. Uh, and okay, so now we need an instance in the game, right?
Sure. Um, Although you're probably going to want to load content because you're going to need to pass the graphics device.
That's right. It won't be loaded yet if I do it in the constructor, right? Okay. And then we're going to want to call batch load from content.
Well, we've got this constructor here, so what we could do is we could bundle this load thing into that, because if we have, we're kind of, like if we're following along with the theme of the existing API, it looks like that. Why is this?
You haven't muted it.
Oh, good. We're on the ball today. Yeah, so we could make it look like that. There's no point in making a separate method call because otherwise we've constructed an object that is not usable. So we could just do that.
Put this stuff in the.
Yep.
Wait, I'm a little confused.
I just grabbed. I'm going to point at your screen here. I just grabbed that bracket and that method and just deleted like that one, and that one, just to merge the two methods. Simple as that. So in theory, we should be good.
I still got some stuff to do. There's still some spots here with these lines.
So okay,
these are coming.
Yeah. So now we have.
Simple.
This should be as simple as doing this.
Make them public.
Ah, yes, of course. Public would help.
I'm not sure we want to call it finished vector lines. We might want to call it end batch or begin and end. I mean, we don't have a begin, but
we can just call it finish.
So much for the API purity.
Yeah. The thing with
we need to get camera.
Yes. Okay. So we'll figure out a way to do get camera next. So, because the thing is, what we really want is just the view project matrix. So we could pass that in, and then we could take this out. So that way,
that's a good idea.
Our line batch system can be used with any way of generating the camera matrix. So let's figure out where we're calling finish and make sure it's got the view project. So what I was going to say, the viewport. What I was going to say was the way that Sprite Batch does like begin end is actually a bit weird, and it's kind of a holdover from like XNA versions 1 through 3. Because of the way it did the batching. Like current XNA, hang on, let's split there, sprite batch sb. Okay, sb.begin. You get these various overloads, and the first one is sprite sort mode, and you've got front to back deferred, immediate texture, and all of these are the same. They all do deferred, except so back to front, front to back, and texture do a sort before it does actually writes it out to the thing. So deferred, which is the default, does the equivalent of just finish. So effectively the begin call does nothing except save that away to happen in the finish call. The only difference is like immediate, which rather than doing a finish, it's like we did, sb dot draw like in every draw was immediately followed by like an implicit finish, which obviously is like ours, same as end.
Right. I mean, that makes sense.
So and obviously begin gets like blend state dot alpha blend alpha blend and so on. It gets all this other crap.
Well, we don't have any options for ours.
Well,
so.
if we were designing this API now, we might want to just do this because this is what's actually happening. So the begin call is actually a bit of a weirdness from the old API. So how are we feeling about this? Do we think we've got everything ready? Your green squigglies are just some kind of you've got something that does that. Yeah. Not actual errors. So
no, the only thing I can think of that I feel funny about API wise is that we've constructed it with a graphics device, but then later we finish with a view project that could have come from a different graphics device. And I was wondering if that mattered, or if we maybe need to make a load content method that passes in the graphics device and not have an instance in there.
Okay, so it's basically what we're saying by doing this is we're locking everything that this line batch does to this particular graphics device.
Right.
And that makes sense because this index buffer, this vertex buffer, and the effect are actual graphics device resources, so they can't go onto any other graphics device. So it doesn't really make sense to be like, if we draw a line or if we call finish, to pass in a different graphics device.
That makes sense. Yeah, and
now the matrix, that's actually just maths. Like that's if we load it up, it's like it's just a bundle of floating point numbers. There's no actual resources in that, so that one's actually fine, and we don't care. Like if the user of this API wants to grab a viewport from somewhere else and shove it in, or literally just like there's no reason that we even need to pass the viewport. We could just say we could do this, and this is gonna obviously do something weird, but we could just pass fixed values and then we get like a fixed size thing, and obviously the zooming and stuff doesn't work the way we expect anymore, but still technically valid. So and there's reasons we might end up doing that if we're making a game that was at a fixed world space resolution. We don't necessarily need to line it up with the viewport. Okay, so that's all of the cleanup done. We've got this nice class. Maybe we'll make a new file for him. So we just get him out of the, what do we call that, line patch. So let's just grab him out. So this is good. So now we have this thing that we can make new projects and all that good stuff, and just have it ready to go. Okay. So, and now this is down to like 169 lines, and it's mostly the camera stuff and the line drawing. Okay, so what we want to do today is we are going to try and basically do circle versus circle intersection tests. So, these two, this one and this one, we can tell that they're intersecting, whereas like these two and those two don't intersect. So this is sort of what we want to come out with at the end of today. Really sort of the simplest form of collision detection. Or it's not so much a collision detection because we're not detecting collisions yet because they're not moving, but we want to detect intersections between circles. So this is like the first, like the simplest kind of intersection test. So what we want to do is we want to take our line drawing and let's just comment it out for now and make a copy of it. We could just delete it outright, I guess, but we'll keep it there so we can look at it. So there's 3 sections. There's the variables and stuff. There's the update part, and then there's the drawing part. So I'll just comment those out for now. So what I've done is I've taken a copy of the update, method. In fact, actually, because we have a rough idea of what we're going to do, we don't really need... yeah, let's start with this. Okay, so... just let you catch up. So first of all, we're going to want the mouse position. I don't know why this is necessarily in there, so I'm just going to take that out. Because we know that like we're doing this line twice, and I just want to clear that up. So we're getting a little bit of cleanup here because that code was looking more complicated than it needs to be. So it's just that. And so what we were doing before is we're like click, 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 click to draw a line. Let's change that up a bit. Let's make it so that we're clicking and dragging to draw a circle. Okay. So sure. Let's write the usage code first because it's good practice. So I'm just thinking, how are we going to do this? Let's we're going to have more or less the same variables and everything, but okay, so we're detecting on mouse down here, like single frame of it going down, but let's detect while the button is down, because that's sort of what we want to have happen. I should probably bring up my...
So pressing and holding down will start the circle, and what, mouse wheel will change the radius, or what do you
I was thinking click and drag out to the radius.
Cool. Yeah, that way we can reuse more of this.
Yeah. Let's bring up my preparation code because I have this coded up already, so I can cheat slightly. Yeah, okay. So yeah, I'm just looking at how I did it before. So okay, we're detecting the mouse going down. So we want to start a circle in this case. So okay, let's yeah, I'm just thinking about how to do this. We want to start a circle, so let's write that. We want to start a circle.
Oh, okay.
And we want to start it in a position. So you can imagine that, you know, we've just clicked. So what we're going to do is we're clicking here. There's like 1. And we're dragging it out to like there as action number 2. So let's deal with action number 1 first. We want to detect the fact that it started and the position that it started. So that should be as simple as that.
Yep.
And then let's go ahead and create those
this here. Okay.
So that's really just some guff. So now we have that. We need to detect the second state, and that is when the mouse comes up while we have a started circle.
Actively first.
So?
Whatever. Okay. Yeah. And then.
So let's have a little think about the code we've just written. Okay. So what have we got? You've got. That's the camera motion is at the top there. Okay, and then you've got this one here. So we're detecting the mouse going down. Now in this case, well, let's just finish up and see what this code does. And, maybe it will be fine. But the concern that I have is if, for example, we miss this condition somehow, you're just going to have a circle like stuck to your mouse. But let's keep going. What do we want to do is we want circles dot add. So we want a list of circles and we want to add a circle. So what do we want? We want
You really need a. Okay. Fair enough.
well, let's think about what a circle is. I mean, it's a
position and a radius.
Yep. So this is looking very similar to this code, but
Yeah.
fairly straightforward. So now all we have to do is figure out the position and radius. So the position we already calculated is what we started at. The radius is going to be the distance between where we're finishing and where we started.
Yeah, that's the word.
Now just draw these suckers. And again, we can probably just copy this code and more or less use it with some modification. It should be like Okay, and all we need now is this. Now, we've copied some code. Well, I've just copied some code out of the update function, so, you know, we might think about later about combining those, but for now it's fine. I think that's everything.
Sorry, you're going a little. Just give me like 2 seconds.
Yep.
I just need the radius.
So
I don't know where you are anymore.
yeah,
right,
sorry,
so,
I fixed a compile bug.
pending circles start. So you don't actually. Okay. Yeah.
Oh, I've got that up here.
What? Oh, okay. Here.
Because, you know, we might be drawing some other things at some point. We might want that. So I figure.
Yeah, I don't have a pending. I forgot to add the pending circle false here.
Yes. So that's. I mean, and if we left that out, we'd quickly find the bug.
No.
Okay, so in theory, we should be able to run this sucker and crash. Good.
Haha, I didn't crash.
Okay, so did we succeed in making
Yes.
circles?
I believe we did.
I've made an error. Left button. Oh, yeah. Last mouse state. So there's always a fun one is what happens when you Alt Tab out. And then Alt Tab back in and then click. So that's always a fun one with the user interaction. Yeah, I click twice and then it disappears. So what we might do is we might think a little bit about this. So if we have a pending circle, what can happen? And that is either the mouse can come up or is active can become false. So that's two different things that are happening. So let's just write what we mean. So that's what we had before. So the two things that can happen are we can lose focus on the window. And presumably what we want to do is just give up at that point. Or we might still be active, and we're checking this because we're doing an else. Or the mouse could come up. And we don't actually care if the mouse was down before. We just care that it's gone up while we're in the middle of that. So I think that does what we want. So that just makes it a little bit more robust. Another thing we can do to make it, well, slightly more robust-ish. Yeah, no, we'll worry about that later. Okay. So one thing that's useful, this is just sort of like a side note, because if you're prototyping things, like you should get used to writing pretty much this exact code, like this bit of code and this bit of code, and this bit of code, because if you are doing a lot of mathsy, engineer, prototypey sort of stuff, and I mean you've seen like the visual test stuff for River City and stuff, you will be writing this code a lot, because you will want, I want to quickly lay down some circles, or I want to quickly lay down some lines, or I quickly want to lay down some polygons so I can test with them. So this comes up a lot, and in my experience, the next two things that you want a way to quickly reset to the starting point. So, usually on escape, it's like, let's clear out the circles. And on backspace is a good one. You want like almost effectively undo, is like erase the last circle. So let's slap those in now.
I don't think I have keyboard state. You still do, I do not.
Do you not have keyboard state? Well, that's very easy to add.
Yeah. But yeah, it looks like I got rid of it somehow.
Yes, and now I remember what I was saying about like trying to keep this bit of code sensible. Like not sensible. What am I saying? Like robust, I guess. Like it doesn't depend on like the user being in a particular mouse set or anything. Because if the user hits escape, we might want to do pending circle false here.
I don't quite understand your is key down and is key up.
That's because I made the same error as just before.
Gotcha.
Okay, so at some point, possibly we need to do that thing. You recall that I brought in this class. Dot key went down.
Right. Yeah, that's probably happening.
That business, so that we didn't have to do that and that, because that starts to get annoying very quickly. So that, in fact, I should add that to the template because it just comes up that often.
We want to clear the circles in here, right?
Okay, so what we were doing is we're removing circles.
Escape is canceling everything, and I thought
backspace. So we want to erase a circle. So if we think about what state the thing is going to be in, so we could be partway through adding a circle. In that case, maybe we want to cancel that. So otherwise, obviously there needs to be a circle. Otherwise, it complains about removing something that's not there.
on that code redundant.
Sorry?
Well, never mind. It's fine. I just why do we need to check pending circle before setting it to false? Because it's either true and we set it to false, or it's false, or it's set to does nothing.
Because it's more of a case of we're using it to trigger this else. So there's two different, just like here, there's sort of two different cases we want to deal with. There's actually two different cases we want to deal with when we hit the back button.
Gotcha. Yep. Yeah, me personally, I wouldn't clear the circles on escape, but because it could be that you just want to cancel that one action, right?
Well,
like
I mean,
in the middle out, you don't want to lay down that. Oh, I guess, yeah, I don't know, just preference.
Yeah, I mean, like this is like
yeah,
these are the buttons I've just got used to doing, but you know,
no, I get it. I like it.
The important thing is sort of the fact that you want a reset and you want an undo.
Yeah, for me, I would wire them both to escape. Like, escape would cancel this or delete everybody. But I can see why. And backspace is sort of like stepping back, which makes sense why you want to kill one.
Yeah, yeah.
But yeah, no, it doesn't matter.
Yeah.
No.
Anyway, like,
cool.
if you want to change this up, by all means. The important thing is you have those options. because they do come up a lot. Okay, so let's start doing a little bit of collision detection, or sorry, I should say intersection testing. So we have a bunch of circles, and we're just going to do this straight in the draw method. So the first thing we need to do is iterate our circles. So we've got, in this diagram here, we have 4 circles. So we need to make sure, can we not zoom in? There we go. We need to make sure that we're testing each pair. So we have this one, and then we have this one and this one, and then we have this one and this one, and then we have this one and this one, and this one and this one, and this one and this one. So all of those iterations we have to go through. So the question would be is, do you know the pattern of code to do that off the top of your head?
Well, I mean, you talking about something efficient or just doing in nested for eaches?
Well, the thing is, okay. So here's sort of another way of talking about what I've got in my head, and that is, we have circles A, B, C, and D, and we want to test some of them against other ones. So say we're going through, we don't want to test A with A, because obviously A intersects itself, but we don't care. We do want to test A with B, and A with C, and A with D. But then we come here, we have B with A. We actually don't want to test B with A either, because we've already done it there. So we don't want to test B with B, and then
permutations, right?
Exactly. So we end up with a thing that looks like this, and this side of the thing is also not done.
I thought you were talking about a code pattern for that. I don't know of any permutation thing out of the box.
So
you usually have to write that.
So the question was basically, do you like, this code for this is very simple, but do you know it off the top of your head?
No.
Okay, I will give it to you because it's very simple. It looks like this: for int I equals 0.
Oh. Yeah. Okay. We're gonna. Yeah. I do know the I and J.
Oh yeah, I mean, now that I'm like started typing, I was like, yeah, you do know it.
I thought you were talking about something fancy like to do permutation without skipping, but yeah, it's just for the wires using the indexer to skip for you.
Yeah. So yeah, so this is one of the cases where it's like you can't go and use a for each. You actually have to do the indexing and stuff. So this is good because we're getting down into like, well, let's treat it like an array rather than just a collection.
Right.
So let's start just by drawing some lines between each thingy. I don't know if I should have done that. Okay.
Not quite there yet.
That's all right. I'm just fiddling. Where are we at?
What happened to my line button? It has no formal code. So, I forgot thickness. Sure thing. You're just going straight green. All right. Where's that first one going? Nowhere?
Okay, so what we're going to do, we're going to make 2 little fixups. I decided not to before, but I've changed my mind. First of all, we're going to... I'll show you 2 neat tricks. So the first one is, well, it's not so much a neat trick, but when we create the circle here, math.max3 that. So we stop getting 0 radius circles. So if I start clicking, we actually get a decent circle. So if I start drawing these circles, you'll notice this is the other neat trick. I'm drawing a pentagram. You know, if I zoom in, we get these massive like lines there. If I zoom all the way out, suddenly you can't see the lines between the circles. So let's fix that up. And the way we do this is trying to remember what we call it. 1f divided by zoom amount, zoom level. And so, you know, basically the inverse of the zoom. So as we zoom in, they get smaller, and as we zoom out, they get bigger. And then, so you'll notice if we zoom, they're visible at all levels, which that is another thing that comes in handy. Just when you're doing this sort of making a like little test thing. So, and as you can see, each time we add a circle, the number of lines increases substantially, and we're probably at some point you'll notice that some of those green lines will start disappearing because our line limit's only 1024.
That's right.
And we never bothered to fix that, and you know, maybe we won't. Like maybe the way that gets fixed is maybe the way that gets fixed is, you know, we just go into line batch and be like, well, now the limit's 10 times larger. Because we're not necessarily using this line drawing for like delivering to a user, so we're not all that fussed about the memory usage. So this is probably, hopefully this is familiar to you, and that is the fact that you can already see it, you know, in this thing here. The number of comparisons we're doing is O n squared.
Yeah.
So hopefully that's all familiar. And this is something that we might need to deal with if, for example, we were doing like 1,000 circles, because that would be what, like 500,000 odd comparisons, give or take. And so, you know, what we might do is we might say, like spatial partitioning, for example, would be like all of the circles on this side and all of the circles on this side, you know, and there's some circles like this one that are on both sides, and we'll test them on both cases. But that like divides the space in half, and so that reduces it reduces the n by half effectively, which
right, and that's why like you see like quad tree, right? That's where that
yeah. So this is like this is the start of what we'd call a BSP, so binary space partition. So we've divided the space in half, and then maybe we divide it in half again, and then we divide that in half, and that in half, and then maybe that in half, and so on. So this is, if you see like BSP trees, this is what it looks like, and it's like, you know, here's the root of the space, and we've divided it in half, and then we've divided that space in half, and divide that space in half, and you know, and so on. And so that's the thing we could look into. Or a quad tree, which is like the same thing, but instead of 2, there's like 4.
Right.
And octree is the 3D equivalent, where you've got like a cube space and you divide it into 8. And so what that does is, you know, if your n is up here and you divide, like, this is your n, this is the worst graph, but like if you've got n up here and you divide n in half, let's call that 0. You divide it in half. You can see obviously that that is obviously a lot bigger than that. So you get a lot of you get a substantial reduction in the number of comparisons you're doing by reducing the n when you have an algorithm that's like n squared. So, and I mean, you don't necessarily just chuck a octree or a BSP tree into these situations. Like, if we know, for example, if the game we're building is like pinball or something, we know, you know, maybe we have multi-ball and there's like 3 balls. We don't care if there's, you know, 3 tests in that case. Like, we don't have to do any of that. But if we were going to do the sort of, you know, physics simulation where it was like 1,000 of these, we're going to have to maybe think about how we do that. In the meantime, what was the other thing that I wanted to talk about? Let's actually do the intersection test. So this is now we've like done all the hard work to get this all on screen and do these comparisons. The actual maths for this is dead simple, and that is we have circle and circle, or we have circle and circle. And you recall from last time that all of the points inside a circle are if this condition is true. So if you've got a point x squared plus y squared, so they've got the distance of the point from the center, so really that's yeah, we'll call it x squared y squared for now, is less than the radius, then the point is inside the circle. So in this case, what we want to know is there a section here where they overlap, basically? Are there points that are inside both circles? And you recall, like, really early on, we had that discussion about Minkowski.
Yeah.
So
Barely,
we had a circle here and a circle here. What we can do is we can convert this problem trivially.
Circle versus point, right?
Yes, to circle versus point. So what we do is we take, you know, this radius, and we basically add the 2 radii together, and we get this situation. Well, this one would intersect, so it would, crap drawing aside, they would look like that. So this is basically what we're going to do. We're going to say if the distance of this point to this point, if this distance here is inside a circle with the radius of that plus that, then it's in this intersection. So that looks like, you know, if the delta x squared plus the delta y squared, delta being like this distance here, so really that should be, ignore the color coding today because it's not very good. If that's less than the radius plus radius of 0 plus the radius of 1, then we have an intersection. So it's like if this business. Then what we can do further is we can square both sides. So if we square that side and we square that side, we can get rid of this square root, so we save a bit of processing. So let's bang that code in now. So we have the distance between the 2 circles. Let's just go with bool intersects. And we'll use a line to indicate this.
Do you mind going back to the graph for 1 second? I know this is probably
To this one. So
yeah.
I
I was
haven't
wondering
done
how. Oh, go
I
ahead.
haven't done the stuff in red yet. So I've just done the
Oh,
length
okay, yeah, yeah. Okay,
times
that's what I
that
was thinking.
bit. Yeah. So I kind of jumped ahead on the drawing.
I just wasn't sure how the two radii did like you squared both sides, but the radii didn't get the square.
Yeah. So I haven't squared them yet.
Right.
We'll just run this and we'll quickly go in and do the squaring because yeah, if I go and click on this distance here, you'll see that there's a square root involved, and we would like to get rid of that square root.
Right.
If at all possible, and it is, so we shall. So hopefully we've got a working intersection test here. And so those ones intersect, but these ones don't intersect. And what's interesting about this, you'll notice that even though we've got a lot of tests going on, we don't have that many intersections. In fact, I can turn off the green thing. Even with a mess of circles, the number of intersections is very low. And that's probably going to come in handy later. So let's fix up the distance. Let's change it to distance squared. Let's do it this way. Just to reduce the amount of text. So in theory, this has got the same result when we can see that.
So why did we do it then?
Just to remove that square root. So it's the same result, but we're doing, you recall all those green lines between these, and that's sort of like an important thing to remember is like how expensive this is. We've made each individual test a lot faster. So if we go back to our graph over here, it's getting a bit messy. Hey, come back. Okay. I don't understand why it's zooming on me. Okay, so this ON squared is actually more like OKN squared, where K is the constant factor of how much processing this takes. So if we remove that square root, this graph here, it goes from being this N squared thing here, it goes to being more like, what's a nice color for this? Orange. We're reducing the K factor, so it's scaling down. So it's more like that. So it's still, because square root's relatively expensive, so it's actually and everything else is quite cheap. So we've reduced the amount of calculations by a lot. So it's still on this polynomial curve, but it's still, it's a lot. We can have a lot higher n before we reach this point here where it really starts to kick upwards. If you know what I mean. Hopefully that makes sense.
I do. I'll need to look at the.
Let me just shut this window because I've got something going on outside.
It just seems like you're doing more work.
Sorry about that. Yeah, sorry, I missed all of that. I was just shutting a window because got some kind of truck.
Yeah, it's not obvious to me I don't understand it enough to wonder. I just will look at the two. Like I've got both of the ways of doing it here. One of them commented out, and I look at this and I'm like, well, aren't you doing more work by having to call distance squared versus distance, and then you're doing an additional multiplication here instead of just summing the radius?
Okay. Well, let's do.
So it looks like more work, but it's not. That's interesting.
I mean, I know you're typing when I do this, but hit F12 on distance squared, and right above it is distance, and you can actually see. This is why it's really handy to have the source code to the library. So you see. Yeah.
It's not squaring the distance.
Exactly.
It's do the distance against a pre-squared value, and we're saving the math. And, I get it now. Okay.
Yep. So that's why they've got distance squared in the API. Otherwise, why would you bother?
Yeah, I don't like the name of it. It turns the square distance between
distance.
Like it sounds like you're doing a square rooting, but you're not. It's the opposite. All right.
So that's
All right.
That's just something that you have to pick up, and that is, if you see in code something that's give me a distance squared or something squared, it's often the case that you're getting that because you've skipped a square root. So if you can do the math so you skip the square root, it's a lot cheaper because square root's relatively expensive even these days. It used to be prohibitively expensive in some cases, but now it's just expensive. Okay. So let's more or less finish up there. I'll just show you what we're going to do next time. So we've got a bit of a preview. So we've done it basically the Minkowski way. We've added the radiuses together and we've compared a point to a circle. What we're going to do next time is we're going to have a circle and another circle. In fact, I'm going to draw them like that. And hey, why not? Let's draw that one there. And we're going to do the SAT, the separating axis theorem. And what that involves is, these two, this one and this one, we know they're not colliding because there's an axis that we can draw between them where they don't collide. Well, where they don't touch, basically. Whereas these two, there's no axis we can draw between those two where they where we can get the axis through without touching anything. So what we do is if we, this is the axis, for example, that we want to show that they're not touching on, we take the perpendicular to that, so that axis there, and we start projecting the circles onto this axis. So this circle here would go from there to there on this axis, so that section there. And this one here would go from there to there. And we can see, that obviously they're not touching, so we can actually compare, this point here is less than that point there. And, if we compare that side and that side, we can prove that they're not touching. Whereas this third circle, it goes from there to there on this axis. And so what we can see there, obviously, is this range from there to there and there to there has this overlapping segment here. And we can not only tell that they're overlapping, we can tell how much and in what direction they're overlapping by getting out this vector here. So that's what we're going to try and do next week. So that's sort of
that. Yeah, for a response, looking appropriate.
Exactly, that's the more hardcore one. So hopefully next time what we'll have is this, this mess of circles. And if they're overlapping, we'll be able to like hit a button, and they will. What's the word for this? Separate, I guess. They will separate themselves from each other by moving, and we'll also once they do that, we will know the point of collision. So we'll be able to say they collided here. If we start adding some physics. And at that point, once we know what the position they're colliding, it's like, okay, you got a circle, you got another circle coming in like that. It can bounce off, for example. So that's sort of what we're working up to. Okay.
That's good.
All right, let's close this one out.